Hello everyone and welcome. In this video we're going to be learning how V8 engines work, starting off simple and then diving into the details of the 3D printed Chevy Camaro LS3 V8 engine seen here. So starting with the very obvious, V8 engines get their name from having a cylinder block in the shape of a V, in this case at 90 degrees, and from having 8 cylinders. In this case, the numbering starts at the frontmost piston on the right and then works its way back. 1, 2, 3, 4, 5, 6, 7, and 8. This engine operates under the same basic principles as any other gasoline 4-stroke engine. Focusing on just a single cylinder, first the piston pulls in air and fuel as it moves downward. Then it compresses that air and fuel as the piston moves upward. Next, a spark plug fires, igniting the air-fuel mixture and forcing the piston downward. And finally, the piston pushes out the exhaust gases on its way back up before the cycle repeats itself. Now, in a V8 engine, this cycle is happening in 8 different cylinders at different times. Instead of multiple cylinders firing at the same time, you want them to be spread out so that power delivery is smooth. For this Chevy V8, the firing order is 1, 8, 7, 2, 6, 5, 4, 3. With 8 cylinders, there is a cylinder firing for every 90 degrees of the crankshaft rotating, which means that at any point in time, there are 2 cylinders on the power stroke. A 4-cylinder engine would only have 1 cylinder firing at a time, meaning the power delivery wouldn't be as smooth. So now let's look at the valve train to see how air flows in and out of the engine. The intake air comes from the top of the engine and into the sides of the cylinder head. The exhaust flows to the sides of the engine, exiting the exhaust valves from the cylinder head. Looking at the cylinder head removed from the engine, you can see that there is a single intake valve and a single exhaust valve, though it's also common to see engines with 2 intake valves and 2 exhaust valves. In this case, the larger valve is the intake valve and the smaller valve is the exhaust valve. The pushrod valve train gets its name from the metal pushrods which activate the rocker arms which open up the valves. The camshaft, located in the center of the V of the engine block, has lobes on it which push the pushrods up, opening the appropriate valves. Here you can see a simple demonstration of the pushrod being used to open up the intake valve. It presses against the rocker arm, seen in red, forcing the intake valve open. The camshaft which operates the valves is geared to the crankshaft, which is what ultimately all the pistons are trying to rotate. For every 2 rotations of the crankshaft, the camshaft rotates once. If we remove the oil pan from the engine, we can see the operation of the crankshaft. The crankshaft is the yellow shaft, and there are added weights to it for balancing the engine. The connecting rods are in brown, which connect the crankshaft to the pistons. What's cool about V8 engines is that the 2 pistons across from one another are actually paired to the same crankshaft bearing. So moving on to those large yellow counterbalance weights. Looking at the first pair of cylinders, you'll notice that as one piston reaches the very top, the counterbalance is directly across from it, balancing out the force. As it rotates another 90 degrees, it now counters the other piston's force. Rotating another 90 degrees, the first piston has reached the bottom, and the weights counter that downward force with an upward force. And then finally, another 90 degrees later, the second piston reaches the bottom, where its downward force is once again countered with an upward force. This is actually balancing out a rocking moment caused by the piston's movement. In full swing, though the whole engine may look complicated from a balancing standpoint, it actually is extremely smooth running, with no first or second order vibrations, and only a first order moment that is countered out through the crankshaft design. All of this is to say that the engine runs very smoothly. Now, this particular V8 is what is called a cross-plane V8, which means each connection point on the crankshaft is offset 90 degrees, meaning the pistons operate in 2 planes, or a cross plane. The alternative is a flat plane crankshaft where the pistons are simply offset 180 degrees, meaning they all operate in a single or flat plane. The advantages of this engine style include its large displacement, which often correlates with generating lots of power, while in a generally compact and very rigid form. They have very little vibration. However, compared to some engines, they have a relatively higher center of gravity and are complex since they require 2 separate cylinder heads rather than just one like an inline engine. Generally speaking, although they are compact in form, they are still quite heavy compared to smaller style engines, though of course while producing more power. If you found this helpful, I have included links to other videos you may enjoy. Also, a huge shout out to Eric Harrell for lending me the 3D printed V8 engine. I will include links to his work in the video description. As always, feel free to leave any questions or comments below, and thanks for watching.